Alright, in this video we're going to talk about graphing inequalities that are not in slope-intercept form. The ones that are in slope-intercept form are easy for us to graph. And there are a lot of different methods that you can use, and in fact that I certainly use to graph inequalities that aren't in slope-intercept form. But to kind of keep things unified and simple for you, my recommendation to you is going to be that when you have an inequality that's not in slope-intercept form, you convert it into slope-intercept form. So whatever the inequality looks like, you solve it and you get y by itself on one side of the inequality. And then you can just use the techniques that we used in the last video to graph inequalities that are in slope-intercept form. The only time you run into a problem with this is when we have an inequality that does not contain a y, because we can't put it in slope-intercept form. And those inequalities that we can't put in slope-intercept form, we'll solve them for x. And anytime we have an inequality where it's just x is greater than some number or x is less than or equal to some number, that's going to produce a vertical line. And instead of shading above or below based on the direction of the inequality, we're going to shade to the left or the right, depending on the direction of the inequality. Outside of that, we're going to put them in slope-intercept form and graph using techniques that we've had before. But when we don't have a y in there, we're going to end up with a vertical line. And we'll do that in the very first example here. We have graphing the inequality x is greater than 3. Okay, so we can't put it in slope-intercept form. First thing I do is I look at the inequality sign. It's a greater than sign, which means that this is going to be a dashed boundary. And all inequalities of the form x is greater than, less than, greater than or equal to, less than or equal to some number is going to produce a vertical line. And it's going to produce a vertical line at x equals 3. So I go over here and I plot 3 on my x-axis, and now I'm just going to go ahead and draw a vertical line through that. That vertical line is going to be dashed because we have a dashed boundary. And now the inequality says that we want x greater than 3. Whenever we have a vertical line, the numbers that are greater than it are going to be to the right, and the numbers that are less than it are going to be to the left. So we're going to shade this over to the right-hand side. And there's the graph of x is greater than 3. Alright, so that's a weird problem for us to look at. Let's go ahead and look at some other examples of inequalities that are not in slope-intercept form. Next one, we're going to graph 2x plus 3y is less than or equal to 12. And the first thing I'm going to do is convert it into slope-intercept form. So I'm going to subtract 2x from both sides because I want to get the y's by themselves. And then I'm going to divide both sides by 3. And when I divide both sides by 3, I've got to make sure I divide the negative 2 by 3. I also have to divide the 12 by 3. And now we have an inequality in slope-intercept form, and we can graph it just like we did in the last video. This is going to be a solid boundary because of the inequality sign. And so I'm going to plot a y-intercept at 4. Use the slope of negative 2/3, go down 2 over 3 to the right, go down 2 over 3 to the right. And then I'm going to draw a solid boundary through those. And now I need to think about shading. And when I think about shading, I want to use this inequality, the one that's in slope-intercept form, to determine my shading. I've got the form y is less than or equal to, which means I want to shade below the boundary line. And so I'm going to shade below the boundary line. And there's the graph of 2x plus 3y is less than or equal to 12. Next example. 5x minus 2y is less than 4. Alright, so I want to convert this over to slope-intercept form. I'll subtract 5x from both sides. That's with negative 5x plus 4 over on the right. And then I need to divide both sides by negative 2. When I divide by negative 2 in an inequality, I'll make sure I flip that inequality sign. And now I'm going to divide both things on the right by negative 2. Negative 5 divided by negative 2 ends up becoming a positive 5 over 2 x. Negative divided by negative gives me a positive. And positive 4 divided by negative 2 becomes a minus 2. Now I've got it in slope-intercept form. Got a dashed boundary. I'm going to plot the y-intercept at negative 2. And then I'm going to use the slope and go up 5 and over 2 to the right. Get some additional points. And then I'm going to graph my boundary. Using my ruler. And now I want to determine where to shade. I'm going to use this inequality here. It's y is greater than, so we want to shade above the boundary line. And so we're going to shade in here. And one last example of an inequality that's not in slope-intercept form. Negative 4y is greater than or equal to 8. We can get it into slope-intercept form by dividing both sides by negative 4. If we do that, we get y. We flip the inequality sign since we divided by a negative. And 8 divided by negative 4 is negative 2. Now you may not immediately recognize this as being in slope-intercept form, but I always think about these as being in slope-intercept form. This really is the same thing as y is less than or equal to 0x minus 2. And so when I go to graph this, I again go through my steps. This is a solid boundary line. I plot the y-intercept at negative 2. And I'm going to draw a line with a slope of 0. So that means it goes up 0 whenever it goes over to the right. And so this is going to lead to a horizontal line, since it has a slope of 0. There's my boundary line. And we want y to be less than or equal to that, so that's going to be shading below. And there's the graph of negative 4y is greater than or equal to 8. All right, and that's some ideas as far as how we graph inequalities when they're not in slope-intercept form. See you next time.